Question number 5. Figure 2 shows a plot of part of the curve with equation y is equal to cos 2x with x being measured in radians. The point P shown on figure 2 is the minimum point on the curve. State the coordinates of P. So, the curve given to us here is the curve of y is equal to cos 2x, and we are required to find the coordinates of the point P here. Now, on the x-axis, we are not given any coordinates marked, and so we are not given any coordinates on the y-axis. Now, we need to relate the graph of y is equal to cos 2x with the graph of y is equal to cos x. Now, first we need to remember what is the relation between the graph of y is equal to cos x and the graph of y is equal to cos 2x. Well, if we take the graph of y is equal to cos x and divide every x coordinate by 2, then we will get the graph of y is equal to cos 2x. However, the y coordinate does not change. Keeping that in mind, if we look at the first trough here, alright, so we see that the coordinates of the first trough are pi and -1. So, in this diagram, we have the first trough. So, the x coordinate of this point will be pi divided by 2. So, let's write the x coordinate as pi divided by 2, and the y coordinate remains invariant. Alright? Continuing with question number 5, I have just pasted an extract of the question here for reference. So part B of the question says, sketch on diagram 1 the curve with equation y is equal to sin x. So I have already drawn the sin x curve here with the red pen. Now some of you may not remember how to draw the sin x curve. So for that, you can always take your calculator and calculate values sin 0 on the calculator, and you will get the value 0. So sin 0 is 0. Then you can put sin 90 and you will get 1. So sin 90 is 1. Then you can type sin 180 and you will get 0. Sin 270 and you will get -1. And sin 360 you will get the answer 0. So now you have all the points, and all you need to do is to draw the graph on the main graph. Okay, so the next thing is how to convert the angles which are in degrees to radians. So all you need to do is divide each angle by 180. So 90 divided by 180 gives half. So you have half and just add a pi to it. So this angle is pi by 2 radian. For example, 360. So just divide it by 180. So you have 360 divided by 180. Oops. So 360 divided by 180 is equal to 2, and just add a pi in front of it. So that's 2 pi radian. So in that way you can remember the sine curve. Alright. Moving on with the part C of the question. So the part C says, hence or otherwise deduce the number of solutions of the equation cos 2x is equal to sin x that lie in the region from x is greater than or equal to 0 and less than or equal to 20. So we need to find the number of solutions between the two curves. Now let us see what is meant by solution. So solution is the point of intersection between the two curves. So this is the first solution. This is the second solution. This is the third solution. This is the fourth solution. In other words, all the points where the two curves meet are the solution of the two curves. So, we need to find the solution right from 0 till 20 pi radians. But our graph is not stretching up till 20 pi radians. So what we can do here is, we can find the number of intersections up till 2 pi radians. So we know that if we multiply 2 pi by 10, we will get 20 pi radians. So first let us find the number of solutions up till 2 pi radians. So let's count from 0 to 2 pi radians. Alright, so this is our first solution, 1. This is our second solution, 2. And this is our third solution. Okay, so between 0 to 2 pi we have 3 solutions. So let's write that down. Between 0 to 2 pi radians there are 3 solutions. Alright, now if we have to find the solution from 0 to 20 pi radians, we have to have 10 times more solution, which means 2 into 10 gives us 20 pi, right? So whatever is the number of solutions between 0 to 2 pi, we need to multiply it by 10. So we had 3 solutions here, so we will multiply 3 by 10, and that is 30 solutions in total. Okay, so that answers to part 1, C1. Moving on to C2, we need to find the number of solutions from 0 radians to 21 pi radian. So we already found till 20 pi radians. Let us imagine this was the point where was the 20 pi radian. So from here till here is a difference of 1 radian. So let us count the number of extra solutions between this distance, which is 1 pi radian. So I have one solution here and one solution here. So there are 2 more solutions. So we can simply write 30 plus 2 is equal to 32 solutions. Question number 6. Given f of x is equal to 2x to the power of 5 by 2 minus 40x plus 8, where x is greater than 0, solve the equation f dash x is equal to 0. So in this question we are given f of x and we need to find f dash x. In other words, we need to differentiate f of x. So the rule for differentiation is we take the power, multiply it with the coefficient of x, and then reduce the power of x by 1. Okay, so let's begin with the part A. F dash x is equal to, now for the first term we take its power 5 by 2, multiply it with the coefficient, and then reduce the power by 1. So 5 by 2 minus 1 is 3 by 2. For the second term, the power of x is 1. So we take the power, multiply it with the coefficient, so we get minus 40. And then we reduce the power of x by 1. So currently the power of x is 1. If we reduce it by 1, then the power of x becomes 0, and x to the power of 0 is 1. Then the third term is a constant, and the differential of a constant is 0. So now all we need to do is to simplify 2 ones are 2 ones are, and we have our f dash x is equal to 5x to the power of 3 by 2 minus 40. Now we actually need to solve f dash x is equal to 0. So we will equate 5x to the power of 3 by 2, which is our f dash x, minus 40 to 0. Now we need to solve for x. So we will make x the subject of formula. So we have 5x to the power of 3 by 2 is equal to 40. Therefore, x to the power of 3 by 2 is equal to 40 divided by 5. We can cancel here, 5 ones are 5 eights are, and we have x to the power of 3 by 2 is equal to 8. Now on the left hand side we have x to the power of 3 by 2. We need x to the power of 1 on the left hand side. Now how to get rid of the power 3 by 2? So if we multiply 3 by 2 with its reciprocal, then we can get rid of the power and the power will be 1. So let's do that. X to the power of 3 by 2 we have on the left hand side. On the right hand side we have x to the 8 to the power of 1. So on either side we will multiply by the reciprocal 2/3. Now here the power cancels and we have just 1. So we have x to the power of 1 is equal to 8 to the power of 2/3. Now 8 to the power of 2/3 means we need to find cube root of 8 and then square the answer. So cube root of 8 is 2. So we have 2 to the power of 2, which is 4. And that answers the part A of our question. Now the part B says find f double dash x. So this is our f dash x. If we need to find f double dash x, which means we need to differentiate this again. So let's start by writing this. So we have our f dash x is equal to 5x to the power of 3 by 2 minus 40. Therefore f double dash x is equal to, now we'll repeat the same procedure. What we need to do is to take the power, okay, and then multiply the power with the coefficient of x and then reduce the power by 1. So we take the coefficient of x and multiply it with the power, and we reduce the power 3 by 2 by 1 and we get half. For our next term, negative 40, since it's a constant, the differential of a constant is 0. Now all we need to do here is to simplify. We have our f double dash x is equal to 5 3s are 15 divided by 2 into x to the power of half. Now in the B part also we need to solve f double dash x is equal to 5, which means we need to equate the value of f double dash x that we got to 5 and solve for x. So we have 15 divided by 2 into x to the power of half is equal to 5. So again we need to make x the subject of formula here. We can leave x to the power of half here and we have 5 on the right hand side. We bring 15 upon 2 to the right hand side, so it turns to 2 upon 15. Now we can cancel the common factors. 2 1s are 5 1s are 5 3s are. Alright, so we are left with x to the power of half is equal to 2/3. But we need to solve for x, so we need to have x and not x to the power of half. So x to the power of half is in fact square root of x. So we have square root of x is equal to 2/3. So to get rid of the square root sign, we square both the sides. So the square and the square root cancel each other, and now we have x is equal to 4 divided by 9, and that's our final answer.